Good day out to you, viewers. My name is Aborisha Dikende. I'm welcoming you to Science Explained. Today, we are going to have a look at the subject chemistry. There are three topics I have in mind to take care of on this subject. And these are the topics highlighted here. The topics are sequel to one another. The understanding of the first will enable you to understand the subsequent ones. Therefore, I am going to do the video in parts. I will treat oxidation number under part 1, balancing redox equation under part 2, then electrode potential under part 3. Please do not miss out on any of these. You are welcome on board. Now, oxidation number. We want to find the oxidation number of nitrogen in the following substances. How do we find oxidation number? We are going to have a look at a series of examples. Solutions. In Roman figure 1, we are given nitrogen ion. Nitrogen ion. That is nitrogen carrying a charge. In this case, it's carrying 3 charges. Since nitrogen is carrying 3 negative, therefore, oxidation number equals -3. Equals -3. That is the answer to that question. For Roman figure 2, we are given a compound NO2, that is nitrogen 4 oxide. For you to find the oxidation number of a particular element in a given compound, you make everything equals to 0. Everything will be equals to 0 because it's a compound. Now, that means I'm finding the oxidation number of nitrogen. I'll write nitrogen plus oxygen. It's very important for every student to know that oxygen has oxidation number of -2, because if you are writing an oxygen ion, it will be written as O2-, as you can see here, O2-. So it's very important. Now, open bracket, -2 times, because of these two, because we are having 2 atoms of oxygen, so we multiply the oxidation number of oxygen, which is -2, by these 2. Then everything equals to 0. So by the time you do your calculation, that will be -xn-4 equals to 0. So what will now be n? N will be equals to +4. That is to tell you that oxidation number of nitrogen in nitrogen 4 oxide is +4. And it's actually this 4 that is used to name this compound as nitrogen 4 oxide. Roman figure 3. We want to find the oxidation number of nitrogen in nitric acid. That is the old name, nitric acid. IUPAC name is trioxonitrate 5 acid. Trioxonitrate 5 acid. Okay. Now, let's go there. Let's say, how do we deal with this? All right. Since this is a compound also, we are going to add the oxidation numbers of the constituent elements together, except that of nitrogen we are looking for, and everything will be equal to 0. That means oxidation number of hydrogen is +1, then plus nitrogen we are looking for, plus open bracket -2, which is the oxidation number of oxygen, then times 3, because we have 3 atoms of oxygen, and that 3 is affecting only oxygen. Everything will be equals to 0. So we have +1 plus n minus 6 equals to 0. So we are going to have +1 minus 6, that will give us -5. So we have n minus 5 equals to 0. +1 minus 6 gives this. So mathematically, we transfer -5 to the other side, it becomes +5. So +5 is the oxidation number of nitrogen in nitric acid. And it is this 5 that is used to name the IUPAC as trioxonitrate 5 acid. Please take note, you must put the positive or the negative sign, whichever case it might be, when you are writing oxidation number. If you don't put the plus, or if the answer is minus and you don't put it there, you are wrong. Please take note of that. So the last one, Roman figure 4, AlNO3 open bracket 3. So this is aluminium nitrate. Aluminium nitrate. The IUPAC name is aluminium trioxonitrate 5. Aluminium trioxonitrate 5. That 5 that is pronounced last is the oxidation number of nitrogen we are looking for. So I can assure you that we are going to get +5 for nitrogen, because NO3 is giving us the oxidation number of nitrogen to be +5. So let's go. The oxidation number of aluminium is +3, because aluminium ion will carry 3 charges, plus nitrogen we are looking for, that will be 3 times n. Why am I multiplying n by 3? Because the 3 outside here is affecting both nitrogen and oxygen. That means these 3 will multiply nitrogen, and as well it will multiply oxygen. All right. Plus open bracket, the oxidation number of oxygen is -2 times the 3 inside, then times 3 outside, because it will be 3 times 3 then times -2 of this. Everything equals to what? 0. Like I told you, we are dealing with a compound, everything equals to 0. All right, let's do the arithmetic. +3 plus 3n minus, plus and minus is minus. 2 times 3 times 3, that is 18, equals to 0. Okay. Now, 3 plus 3 minus 18, that will be minus 15. That means we have 3n minus 15 equals to 0. So, now, what will now be 3n? Minus 5 will come, minus 15 rather, will come to the other side. It becomes plus 15. So, 3n equals plus 15. You can see I'm including the positive sign. So, divide both sides by what? 3 to get the oxidation number for nitrogen. 3 cancel 3 here, we have only nitrogen. Then this will give us plus 5 because 3 in 15 is 5. You can see that we got plus 5 as the oxidation number of nitrogen, which is the last pronounced number in the IUPAC nomenclature for this aluminium trioxonitrate 5. These are further examples on finding oxidation numbers. The first question is asking for the oxidation number of sulfur in SO4 2-. We are looking for the oxidation number of this. Now, in this case, since it's carrying a charge, so that means we will add up everything together. So we are adding everything together and it will be equals to minus 2 because it's carrying 2 negative charges. So S plus oxygen is minus 2 times this 4. Everything equals to minus 2, which is this one. Okay. That will be S plus times minus is minus, and 2 times 4 gives 8 equals minus 2. So S, which is sulfur, will be minus 2 plus 8 because when this one comes here, it becomes positive. And sulfur will have plus 6. So that's the oxidation number of sulfur in this case. So everything added together equals this minus 2. So let's take note of that. Same thing applies to Roman figure 2. MnO4 minus. So we are looking for the oxidation number of manganese. So manganese plus open bracket, oxygen has minus 2 as oxidation number times 4 because we are having 4 atoms of it equals to minus 1 because we have only a single charge here. So Mn plus times minus will be minus 8 equals minus 1. So Mn, that's manganese, will be minus 1 plus 8. And that will give us plus 7. So the oxidation number of manganese here is what? Plus 7. So if I want to pronounce it, that will be manganese tetraoxo. It will be tetraoxomanganate 7. Tetraoxomanganate 7 ion. Now for figure 3, NH4 positive, that is ammonium ion. So it's going to be, we are looking for that of nitrogen. I didn't underline this, so I need to. Okay, we are looking for that of nitrogen. So that will be nitrogen plus open bracket, oxidation number of hydrogen is plus 1 times the 4 at the bottom of it, which means 4 atoms of hydrogen. Everything equals to plus 1 because it's carrying only a single positive charge. So N plus 4 equals plus 1. Now, so what will now be N? N will be 1 minus 4. That's minus 3. So oxidation number of nitrogen is minus 3 in ammonium ion. Finally, we want to deal with the last question, which is from figure 4, K2 Cr2O7. So this is what we are looking for, chromium. So potassium has oxidation number of plus 1. That will be plus 1 times 2 because of these 2 atoms of it, plus 2 times chromium. We are looking for chromium, plus minus 2 times 7, which is for oxygen. Oxygen has oxidation number of minus 2 times this 7. Everything equals to 0. Do not forget this is a compound, not a radical like this. So it will be equals to 0, as we have done in the previous examples. So we have plus 2 chromium, then minus 14 equals 0. Now, plus 2 minus 14, that will be minus 12. So we have 2 chromium minus 12 equals 0. When minus 12 comes here, it becomes positive. So 2 chromium equals plus 12. Dividing both sides by 2, chromium will have plus 6. That's the oxidation number of chromium. This is the end of part 1. That is finding oxidation number of elements in given substances. At the end of watching this my video, if you are interested and you are impressed, please do not hesitate to subscribe to my channel for subsequent release of other videos, and as well share and like the button. You can try this. Please, see you in part 2. Till then, take good care of yourself.